Let's take a few minutes to talk through our instruction set. I've left a copy of this spreadsheet in the resources section. Now it's just the spreadsheet that you've been using previously, the one we used to generate the microcode, and the second sheet for that's called commands. When you click on that, it'll take you through here. Okay, so all we're really going to be bothered with right now is this column G. In this column I've generated examples of the type of command that we have. Now if we take out the value for the don't cares, okay, so there's an X here, so if we take that out and then we count how many we have, we run down through here and it says here actually at the bottom there's 90. Okay, so we've got 90 different commands that we're going to be able to talk our way through. So I'll just bring the X back in because these are going to be spare positions for extra commands. So let's get started. The first one is the data command. So this is an immediate command. Now I'm not going to mention every type of addressing mode for all of them. I might just mention ones now and again, but this is an immediate addressing mode, and the data command puts a literal value either in a memory location or it puts it into a register. So you can see here it takes the value 5, and remember we know it's literal because it's got a hash in front of it. If it doesn't have a hash in front of it, then it refers to a memory location. So it puts 5 into register RB, and you can note here I've got the data command. It's the opcode binary for it, the opcode hex. Now in this instance here we're going to have our register A and register B. So this column here is actually register A and this column here is register B. So the way it works, as I mentioned in a previous video, we're going to have the opcode, which is 8 bits, then we're going to have a 4-bit for a 2-bit, sorry, for a we're going to have our opcode, which is 6 bits. We're going to have 2 bits for our addressing mode, and then we're going to have 4 bits for register A, which is the source, and 4 bits for register B, which is the destination. So we always work it through our commands so that we go from the source to the destination. So it goes opcode, source, destination. Okay, opcode, source, destination. So in this one here we're going to have that data hash 5, so it puts the value 5 into register RB, and you can see that in this instance here register A is not getting used, so I've just got a cross here for register A. Okay, and because the source in effect is just the next memory location, it's the immediate mode. Now this one here puts the value 5 into the memory location 500. The load and the store command, the load takes the information from the memory into the register, and the store command takes the information from the register into memory. So load is memory to register and store is register to memory. So in this instance here we're going to load the contents of the memory location 10 into register RB. Now here's one of the addressing modes. So this is an indexed addressing mode. So what we're going to do is, again, we've got our source and our destination, but our source memory location now is the register A plus the index register. So we go to a memory location which is determined by the value that's in register A plus the value that's in the index register. So if register A contains the number 10 and the index register contains the number 10, we add the two together, we get a value of 20. It goes to memory location 20 and it pulls out that value and it puts it into register RB. Now if it's got a square brackets round about it, it's going to be a pointer. So we say load RA, RB. So we know we're going to load the contents of this RA within brackets into register RB. So what happens is, if RA says got the value 10, it goes to memory location 10. But then it looks into memory location 10, and let's say memory location 10 has a number in it, which is say 50. Well, that 50 is a pointer to another memory location. So it goes to memory location 50 and it finds the operand in memory location 50. Okay, so I'll say that one more time. Go to, if RA has the value 10, it will go to memory location 10. It goes into that memory location, and let's say it finds the number 50. So that is another memory location. So it goes to memory location 50 and it gets the operand from the contents of memory location 50. In this one here, load RA, RB is a simple one. Load the contents of the memory location which is given in RA into the register RB. And we've got the store. So you see the store works the other way around about, because the source, the source now is going to be register RA, and the destination is going to be somewhere in the memory. So we're always going from register RA. So store the contents of register RA into a memory location 10. Store the contents of register RA into a memory location which is given by the contents of register RB plus the index register. Store the contents of register RA into a memory location pointed to by RB. So it goes into RB. Let's say RB contains 10. It goes to memory location 10. At memory location 10, it's got a value in it. So let's say it's value 50. So we then go to memory location 50 and we store the contents of register RA in memory location 50. And this one's straightforward. We store the contents of memory location RA into the store the contents of the register RA into the memory location which is given in register RB. So if register RB contains the number 20, then we go and store the contents of RA in memory location 20. Now we've got 4 jump commands here. So this one, JMP, it jumps to memory location 10. This one will jump to a memory location which is given by the contents of register RB plus the index register. This will jump to a memory location which is given by the pointer RB. So again, the pointer, if RB contains 10, it will go to the memory location 10. If it gets memory location 10 contains the value 50, then it will go down to 50. When it gets to 50, 50 will contain another number which will be say 25. So it jumps down to that memory location which is contained there, which is memory location 25. And that just jumps to the memory location which is given in register RB. So most of the rest of these follow this same kind of pattern. I've tried to keep it reasonably similar, but it doesn't completely follow the pattern that you see here. But you can see the next one does. We've got a jump to subroutine, and the jump to subroutine does the same as the jumps above. Okay, they're just the same layout. And the jump to subroutine was slightly different because when we did the jump to subroutine, it saved the return address in the stack. So we can use this and along with the return command, which is further down the list here, in order to return back from the subroutine. And I won't talk through the different addressing modes, but they're the same as the ones above. And here, again, the addressing modes are very similar. We're going to push the value 5 onto the stack, so we can just put the literal number 5 onto the stack. We can push the contents of register RA onto the stack, and then again we can push the contents which are pointed to by the contents of register RA onto the stack. I'm not going to talk through this again. You know what the square brackets mean. I've talked through that a few times. And this other one here is slightly different from the ones above. This is going to be a post increment. So it's going to push a value onto the register. So it goes to register RA. If register RA contains a value 10, then it goes to that memory location 10. Memory location 10 contains another memory location, which is say 50. It goes to memory location 50, finds the value in it, which is maybe 25, and it pushes that value 25 onto the stack. And then after that, it post increments. So it increments the value that's in, not register RA, but it increments the value that's in the position pointed to by register RA. And the pop command does the same as above. The only difference is it's taking the information off of the stack. So you can see here that pop, you see the 10 doesn't have a hash because we're referring to a memory location. We're taking a value out of a memory location. So that's the 4 pop commands. Now this one here is slightly different. I didn't actually mention above, if we look at the data command, there's actually 2 commands here which are actually 3 bytes long. So this data command is actually 3 bytes long. We've got the actual command, the data, which takes up 16 bits, and then we've got the hash 5, which is in the next memory location, so that's the immediate, and then the 500 is in the memory location after that. So there's 3 different memory locations for that one. So you can see I've written byte byte, because in this case here, it's an immediate mode. So if you head back down here, we've got the move. So that's move the contents of memory location 10 into the contents of memory location 20, into memory location 20. And you can see here that it's going to be a 3 byte command. And we've got the move RA RB, so that move the contents of register A into register B. So the move command does move from memory to memory, or move from register to register, but I don't use the move command to move anything from register to memory or memory to register. Okay, we do that with the load in the store. We've got exchange RA RB, so it takes the contents of register RB and RA and just swaps them. And we've got the add, so we add the value 5 into the contents of register RA and we store the value in register RB. And this one here, we add the contents of RA to register RB and we store the value in register RB. And this one here, we add the contents of memory location 200 to register RA and store the value in RB. And this one here, as a pointer with post increment. Now I'm not going to talk through this again. We've talked through, so it does the same addition, but it's a pointer with post increment. Don't worry, we'll go through an example of one of these in another video, and you can see how we actually build it in microcode, and you can see it working. And when you see it working, you'll understand how it works completely. This shift, now the shift value, so there's shift right and shift left, but we can actually shift right by a particular value. Okay, so this shift hash 4, it means shift 4 positions. So we can shift 4 positions right, the contents of register RA, and then we can save the value in register RB. And there's a shift right register RA, which will just shift right the contents of register RA by a value of just 1. Okay, so there's no number there associated, it just shifts it by a value of 1 into register RB. And we've got a shift right by a value of 4. Okay, so that 4, it can be any value, 4, 5, 6, 7, 8. So we're going to shift by 4 positions, and this one here is slightly different. You can see there's a bracket, there's a curly bracket. So there's a few commands, not very many. I think there's 3 or 4 that have actually got curly brackets. Now in this instance here, I needed to generate a different nomenclature here because the square brackets refers to a pointer. Okay, so in a pointer one, you go to the memory location. The memory location contains another memory location which goes down, and you have to go down to that memory location to get the operand. So in this instance here, I just wanted to point to the contents of the memory location. So what I wanted to do is shift right by 4 positions, not the value that's held in RB, but the value that's held in the memory location that is in RB. So for example, RB is going to contain the number 10. You go to memory location 10, and then you shift the value of that memory location 4 to the right. Okay. And we've got another shift here as well, which is, as we've mentioned before, it's a post increment, and I won't talk through that again. And we've got the same for the shift left, so they're exactly the same ones, but they're shifting left, so we won't talk through those. We've got a not 700, so in this here we're knotting or inverting the contents of memory location 700. So the 700 is just a random number I've picked out just to show you how it works. And we're going to knot the contents of register RA, put it in the RB, knot the contents of register RA. Now you see it's got the curly brackets here. So we're knotting the contents of register RA, and we're putting it into a memory location which is an RB. So RB contains the memory location, and we put that value in that memory location. Now it's a bit dull listening to this, I'd imagine, but at least you can get through it just once. And if you don't need to listen to the whole video, you can always come back at some point if you're using some of these, and then you can fast forward to the one that you're interested in and you can listen to it, okay, me describing it. And we've got the not RA, and again it's a pointer and it's a post increment. And we get through the same. Now it's be quite quick now because we've got the same for the ands as the nots. We've got the same for the or. We've got the same for the exclusive or. Now we've got the same for the compare. The compare is slightly different because I've adjusted that a little bit. So it actually goes like this: compare array. Right. Now the compare is slightly different because once we get through the compare, we don't actually place a value anywhere. We just compare two things, and when we compare it, one of the flags is set. Okay, so we're comparing the number 5 with the contents of register RA, comparing the contents of register RA with register RB, comparing the contents of memory location 200 with the register RB, and that's comparing, let's put a comma in here, and it's comparing, now this is the operand, so it finds the operand here using the pointer with an increment, okay. And finally, well not quite finally, but well, we've got a few more to go, not too many. We can increment and decrement, so we can increment the contents of register RB, we can increment the memory location 200, and we can increment the contents of memory location 200. So these are slightly different. This just takes the actual memory location 200, and in fact it changes it so it points to memory location 201, and this takes the contents of memory location 200 and increments that value by 1. And we've got the increment the pointer RA and its post increment, and it puts the value into register RB. And the decrement is the same, so it's the 4, but it's for the decrement. And we've got the jump command, so there's actually going to be, it's a jump if, so there's actually going to be quite a few, there's going to be 16 of these, okay. Now we'll go through the actual jump if commands at some other point, okay, because if I change the circuitry in order to allow us a lot more leeway in how we define our jump ifs. But we'll get to that in a different video. So we've got the jump to so we could have a jump of carry, jump of 0, jump of carry and 0, and there's a whole load of different variations on that theme, but I've only just used the jump carry here as the example. So jump of carry to memory location 5, jump carry to the memory location which is held in RB, and then jump carry to the memory location which is pointed to by RB, the contents of RB, and jump carry to the memory location that's pointed to by the contents of RB and its post increment. Now this is exchange the registers RA and RB, so any values in the registers can be changed. So we've got an exchange EXGM, which is exchange memory. So EXGM is exchange memory. So we're exchanging the contents of the memory locations that are in RA and RB. So for example, if RA is the value 10 and RB is the value 20, then we're pointing to those memory locations 10 and 20, and we swap the values within those memory locations. So this is different from the other one, which is EXGR, which is the exchange register, which just swaps the values that are held in the two registers. Okay, so one's a register swap and the other one's a memory swap. We've got our clear flags. We've got an end command. Again, we've got the subtract, a multiply and divide, and those follow the same process of the ones we've seen before and the same addressing modes. We've got our return, which is used along with our jump to subroutine. So we've got a jump to subroutine, it goes into the subroutine, we use the return function to return back to the previous subroutine. And we've got another one here which I added in lately, which is clear. So it just sets the values to 0, so we can clear the contents of any of the registers. So clear RB. So not the most exciting video, but we have gone through all of the instruction set, and that's the 90 values, 90 instructions that we have. So quite a powerful lot of instructions that we have there. And the great thing is that we've got 16 possible enable sets. So the most complicated instruction there maybe takes about 8 or 9. So we can build in really quite complicated instructions if we wanted to. But that's enough for now. One other thing to note, as I mentioned in our video, the registers are given by these 16 values here. So it counts off 0 to F. Okay, so that's the 16 values. And the registers run R0, 1, 2, 3, 4, 5, floating point unit index, stack, flags, temp, control, instruction address register, accumulator, and memory address register. So each of these registers can write to all the other registers, so they can all talk to each other. Now I'll talk through the jump routines in a different video, because I said I've changed the circuitry a little bit for that. So probably a bit of a dull video, but it's there for you. If ever you're wanting to find out how the commands work or what the commands are, you can always come in here and have a little listen. So thank you for listening. I'll get you on the next video.